obviously, I was thinking of some interesting things to show. And one thing I thought that would be really suitable to show is we have a demo that we've been doing at a number of different events called the Interactive Vehicle Manual. And this is like a good example of our live streaming API that we have. So first question, has anybody used Gemini Live? Quick show of hands. Okay. Probably about like a third of people. Has anybody developed anything using the live API? One or two. Ooh, fantastic. Then you are the right people for me to talk to. So, so if you didn't know, Google obviously has a number of AI models, the Gemini series, and they have a live API, which is a bidirectional streaming API. So with it, you can send audio and video, and you can talk to the model and you get responses back. So like, compared to like, traditional systems that have a speech to text and then an LLM and then a text to speech model, we actually have a cascaded architecture. So the model natively understands the audio, and you have the option of having a TTS output, which you can control, or we do a full kind of audio to audio mode. So I'm going to see if I can show you a couple of different examples of this. And what's really cool about this technology is that you can use it to, say, for instance, show like images of things around the room with your phone, or you can share your screen and you can talk to the model about your screen. So basically it's having a live interaction with it. And one of the things I want to talk about a little bit is some of the challenges that come with talking to like an audio to audio model. Some of the things that it's very powerful for, like its understanding of like nuance and tone and other stuff like that. And some of the things that's kind of harder to get it to do, like, reliably take actions and basically do the specific tasks that you need to do. So I'm hoping to show you that to use these kind of tools, you need to kind of switch your mindset from like, traditional kind of structured, tested like workflows to a more kind of exploratory mechanism to understand what the models are capable of and how to get them to reliably do the same actions. So I'm going to show you a couple of slides from here, which is our vehicle demo. So actually, do you know what? We're going to go straight. I'm going to show you the video. Who better to explain what's happening than past me? So have a look. So you can type messages to Gemini, but not only that, you can actually talk to Gemini as well. What I'm going to do here is I'm going to open the microphone so you can talk to Gemini, and then Gemini's going to explain to me how to drive this car. Let's go. Hello there. Welcome to the driver's seat of the amazing Quantum H3 Genomic Factor 2. I'll be your instructor today. The model understands a lot about the game, the controls of the game, and a little bit about Formula E. We can give you some history about it. How do I drive the car? Let's get in. I have a gamepad, so what are the controls for the gamepad? Of course. Okay, so you're holding your phone. And the left trigger is your brain. And the way we kind of built it is using like a framework. So you can take an application like this or a game, and then you can pass in the audio and the video input, and then give it to Gemini, streaming through the live API, and it's able to respond to you and talk to you and give you output. Where am I, by the way? I'm exactly racing. And the model itself is also able to do things like function calls. So it can help by like toggling driver assist. Can you tell me how fast I'm driving? You're currently traveling at 2.5 kilometers per hour. No, that's super useful, thank you. And we built this on top of an application called the Live API Web Console, which is basically it's like a framework boilerplate for building applications. So if you're interested, you can go to AO Studio, you can try the Live API, you can talk to Gemini. And if you want to build something, you can use the Live API Web Console and download that, build that, run that in your application yourself. So there you go. So I hope that painted a little bit of a picture about what it does. We took this particular demo to obviously Google I/O and then a number of different I/O Connect events, Cloud Summit events in London and other places around the world. And one of the cool bits is we got to basically use it with like a full driving simulator rig. So you imagine the users would come and they'd sit in the vehicle and they'd sit down and they'd say, what do I do? And the model is designed to understand a lot about the vehicle itself, understand how to actually control the game, and is able to kind of give you like what we described as an interactive manual, like instructions. So instead of you reading like 20 pages of how do I operate this, you just ask the questions that are on your mind, like what are the controls, like what button do I need to press to turn on the boost, like how do I configure things within the menu. So in order to do that, this is the architecture that we used. Loading. Yeah, so using a live API, we're streaming the audio and video, basically, of the game. And that goes in through the capture module, then sends it off to the model directly. So there's nothing in between those steps. Like, you're sending the raw data straight to Gemini, and Gemini is processing it. Then what it does is it will respond with an audio stream and also with actions that it can take. So we've actually, in this example, we've programmed it to understand that it can toggle the driving assist of the car. So if someone's particularly struggling, or that they're spinning out a lot, you can say, like, turn on traction control, and the model will take that action for you. So that's combined basically with like a task management system, and we have these game profiles, and all the game profile does is just tell the model what actions it can take within the game. And I'll let you in a really dirty secret. All it does is just press a button on the keyboard to actually trigger the action in the game. So what's cool about this is that we haven't built the integration straight into the game. We've built it as like a wrapper around it that you could just apply to any application. And obviously you have like this little UI debug console, so you can see what's going on, and I'll show you how that bit works as well. And you can just do this today. If you go to the GitHub project and you download this app here, all you would need is like a set of system instructions to explain to the model about the game, and then you'll be good to go. There's nothing custom, nothing bespoke, which is the main takeaway from this at the end. So you could definitely try it. So should we try and do a live demo? Yeah, that's what we're all here for, right? So usual caveats: if it goes wrong, we applaud because. Right, so I'm going to cheat a little bit. As you may have noticed, I don't have a gamepad or a driving rig. So what I'm going to do is I'm going to play a video, and I'm going to have the model look at the video, and I'm just going to ask it questions about the video. But imagine I'm kind of like sitting in the driver's seat. So let's start it up. There we go. Let's pick the right version. There we go. Load the model. And I should have somewhere here. There we go. There's my game. Let's just start from the start. And then I will go into here. I've got to share my screen. Once I share my screen, then Gemini is able to actually see this. And then hopefully I can jump back. And we will see whether... Hey there.
Hello there. Welcome to the driver's seat of the amazing Formula E Gen 3 in R Factor 2. My name is Alex, and I will be your instructor today. I'm here to help you get familiar with this fantastic car. No question is too silly, so please ask away. To start, are you wondering what Formula E is? Or do you want to know how to drive the car? I see that you are in neutral. The dashboard indicates N. To start driving, you need to shift into first gear. With your current gamepad configuration, you can do this by pressing the right trigger.
I don't have a gamepad, but let's not worry about that now. So how do I go into the next gear, you said?
All right. To shift up to the next gear, you need to press the upshift button, which is defaulted to the left Alt key on the keyboard. Give that a try.
Okay, what if I was using a steering wheel?
Great. Since you're using a steering wheel, have you mapped the upshift control to one of the paddle shifters on the wheel?
I have
Use for upshift.
I have done that.
Okay, I see you're still in neutral, but the car may not have shifted into gear.
Okay, so how do I go forwards?
The way to go forward in the Formula E Gen 3 car is to apply the throttle, which is by pressing the rightmost pedal in your standard sim racing pedals.
Okay, I'm doing that now. I think it's working.
Great, you are up and running. What next? Do you want to go faster? Or are you happy just cruising for the moment?
Yeah, just can you give me some background about Formula E? Tell me a little bit about the sport, because I have no idea.
Certainly. Formula E is an all-electric international single-seater championship. It's a bit different from other motorsports because it focuses on energy management. The Gen 3 cars you're driving are capable of speeds up to 200 miles per hour.
Okay, you're right. I want to go faster. How do I go faster?
The first thing to check is the speed limiter. Make sure that is not enabled by pressing the red button on the left side of the steering wheel.
Okay, let's do that. Okay, yes, I guess I'm now going faster.
glad you're picking up speed. Now that you're rolling, are you interested in learning about tech mode, which gives you an extra burst of power?
Sure, tell me about that.
Great. Attack mode is a unique feature in Formula E. It provides a temporary power boost, adding an extra 50 kilowatts to your car's output for a limited time. Activating attack mode involves a two-step process.
Okay, hold on. Before we get to that, I'm struggling to brake. Is there any reason why it'd be hard to brake?
Sure. One common reason is that the Formula E Gen 3 car uses a regenerative braking system, which might feel different than what you're used to. The brake pedal primarily controls the amount of energy regeneration blended with front friction brakes. Are you pressing the brake pedal firmly enough?
I am now because I've stopped. Oh, can you read what's at the side of the track?
All right. Looking at the side of the track, I see the words Google Cloud displayed. Is there anything else you'd like me to identify?
Yeah, I've got one tricky one for you. Can you tell me how fast my last lap was?
I sure can. I'm looking at the bottom right of the screen, and your last lap time was 1 minute 45.453 seconds.
Hey, okay, we got there. So there you go. So
Fantastic. Is there anything else I can help you with today? Perhaps you want to go over energy management techniques.
I would love to add another time. Yeah, so there you go. So thank you. So you can see we combine like a different kind of natural conversation, asking questions to kind of also interrupting the model. I think by now, a lot of folks who've been using AI voice models for a while understand that humans aren't quite ready for this from like a interaction perspective. And what we want to try and do is make conversation more natural, make voices more natural, and get it to the point where it's almost kind of seamless. So one thing we find when people use this a lot is that they don't interrupt the model. They just kind of let it talk and it will just kind of waffle on for hours and hours and hours. So you want to be able to give people control so they know how they can interact with it. One way you can do that is you can control a lot of this behavior through system instructions. So the language models themselves, they're very, very good at following instructions. So all the information that it told me there about like what's in the vehicle and how to do the different controls, what the buttons do, is in basically a 20-page manual that we fed to it. And it's very good at pinpointing specific things out of that data. So when I said I'm using a steering wheel rather than a gamepad, it adapts its knowledge and looks at a different section of the manual. And one thing we were finding in the demo was that people were driving really slowly because they had the pit limiter on. So we added a section to the system instructions specifically saying causes of slow speed might be you're not accelerating hard enough, or you're in the wrong gear, or you might have the pit limiter on. So by putting that information within this prompt, the model is able to reliably pick it out because we've kind of given it like a common set of causes. So you can have like kind of very structured workflows, but one of the big challenges that we found is very difficult to kind of evaluate this because the best way to do it really is to just talk to it. You can have pre-recorded audio, but obviously the path that the model takes is going to be different every time. So that's one of the challenges to look out for.